Hello again. This time we're going to learn for loop and while loop. The for loop and the while loop. Quickly, the syntax of the for loop in OCaml is as follows. Although always remember that OCaml supports a sort of limited form of the for loop that we are familiar with. You know, the for loop from Java and from C and from other languages. In OCaml is quite limited, and usually looping, in OCaml you can use for loops or while loops if you want, but usually recursion is very easy to do and well supported in OCaml. And when we have data structures such as lists and arrays and things like that, they actually have sort of already existing functions to loop through the elements of those data structures. Anyway, the for loop and the while loop, the syntax looks like this. For the for loop, we have the for keyword, and then we have a certain variable. We don't have to declare it, we just have a variable, and then we give it a start value with single equal, and then to, that's again reserved keyword or keyword in OCaml, to an end value, do some expressions, one or more expressions, and then we end it with the word done. So that's sort of the value going up, I'm sorry, the value of the variable is increasing by one or by a certain amount every time the loop iterates. Whereas another form is down to, so for the variable to basically go down or to decrease, the opposite of to is down to. So this is increasing and this is decreasing, but exactly the same way. Whereas for the while, we have the while, a boolean condition, so not a variable, just a boolean condition, one or more conditions of course, do, and then one expression or more, one or more expressions, and then we end it again with done, similar to the for loop. So for variable, to, begin, start value, end value, do the following, more, one or more expressions, done. Likewise for the down to instead of to, and then for the while loop, while condition, one or more conditions of course, do some expressions, and then the word done. For the conditions, I may have not explained the single equal and double equal well in the last few videos, so this time I'll try to explain it more. But let's go to our um, top loop and try to have some for loop. So let's say, for example, for a for loop we can say for example, I equals 0 to 10. Remember we said begin and end values, do the following, and we can have more than one expression. For example, there's a function in model pervasives available already called print string. So we can print string and say, for example, value of I is, and then maybe we can have sort of slash n for a new line. So close that string. Remember we close statement for a semicolon, and we can actually say, for example, let something equals this in the following, but this will return um, a unit, i.e. nothing. And then we can say, for example, print print underscore int, and then we can say, for example, I semicolon, and then we can close the loop using done. So if you notice here, we have value of I is 0. I just needed to format it properly, but as you can see, value of I is 0. I should have added another new line here, so let me just copy and paste this in my text editor and add a new line quickly, so the formatting looks much better. And then we can print another string here just of a new line, so things are clearer. I'm trying to demonstrate the use of semicolon and multiple statements at the same time. So in a if or else statement, we could have used begin, end, or opening and closing parentheses. So value of I is 0, value of I is 1, and then we could have maybe, I'm sure you get the idea. I don't have to waste much time on this and bore you with these ideas, but if we do it like that, it'll look much better, I'm sure. So if we just do it like that, okay, value of I is 0, 1, 2, 3, and until 10. So remember that I is 0 is included now, so these are actually 11 values, not 10. Yeah, 0 is included, 0, and we stop at 10. And if we want to do it down to the other way around, then we can say I equals, for example, 10 down to 0, and then just display or print out the values of I, like we did for the increasing one, so from 10 till 0. If I by mistake, for example, say for example 0 down to 0, what do you think will happen? Do you think it'll iterate at least one, it'll execute at least once? I think the answer is yes, because 0 to 0. But if I say for example let's say 2 down to 3, then it will not execute, because that doesn't make sense. See, it returns nothing, unit, empty. Right. Now, just quickly, this idea of returning units, we said print string, it prints, but it's actually an expression and it returns something, whereas in this case it returns nothing. But if we try to see what that means, so let me just say for example let s equals print string. So print string just outputs something, test, and does nothing else. Yeah, close it. Notice that s is actually of type unit. Yeah, s is of type unit. These two empty parentheses, that means it's actually unit, it's actually empty, nothing. So everything returns a value. I hope you get the idea of OCAML now, of the functional programming, that every expression is actually, or every statement is actually an expression, and it can be, or it actually evaluates to a value, although the value can be a unit value, which is equivalent to nothing. Now for the while loop, we just have a boolean condition. So for example, if we say if I do, like for example, let's say for example let I equals 4, yes, and I can say while I is less than 5, which is true, do the following: print string test. Done. If I execute this, this will go forever, because I will always be less than 5 and I'm not modifying the value of I. Now, to do destructive programming, i.e. to declare a variable and then modify its value, we'll come to that maybe in the next video. But now just look at this. It'll just execute forever until I do Control C to interrupt it. Yes, I hope that makes sense. Now, going back to the idea of the Boolean condition, again we can have multiple conditions like we did for the if statement, where we use logical and or. Now, I just wanted to recap on the idea of the single, of the equality, of the of the deep and shallow equality and inequality. We said before that there's a difference between using single equal or double equal. So always remember that a single equal checks for structural equality, i.e. two structures or two objects are exactly the same, whereas the double equality only checks the physical equality, i.e. the value. This will become obvious when we use sort of larger data structs rather than the primitive types, int, float, and things like that, and boolean. This will become obvious when we use proper structs, or maybe if we use classes and objects. If you want to think of this, if you are coming from a Java background, this is similar to the difference between using the double equal and the dot equals in Java. Yes. So OCaml, we can use the single equal on sort of every kind of value. Yes, remember this. Single equal for OCaml, we can use it for every kind of value. Whereas in Java, for example, we don't have the dot equals in every type. Yes. So in int, for example, we don't have it. We have it in string, for example, but not in int. So for float, is slightly different when it comes to OCaml. We shouldn't use double equal for float in OCaml, and the the reason is that floats are usually or floating point numbers are sort of reference types. So it's much better to use single equal and not use double equal. I hope that this makes sense. This will become clear when we use objects, proper data structs, and things like that. We'll come to that in the future. For now, thank you very much indeed for watching. In my next video, I think it's going to be a short video, but there I'm going to show you how to do some destructive programming, i.e. to declare a variable and then modify its value rather than having to or do sort of like mutable variables. Mutable variables mean the ones that we can actually the ones for which we can change the value. Thanks very much for watching, and I'll see you next time.